Hello everyone, I would like to present a topic about direct memory access or commonly known as DMA. First, let me explain about what direct memory access is. Direct memory access is a feature in a computer system that allows certain hardware devices to transfer data directly to or from the computer's main memory without requiring continuous help from the CPU. In a normal data transfer processes, the CPU controls every step. The CPU receives data from a device, processes it, and then stores it in memory. However, this process can make the CPU busy and reduce the overall performance of the computer. DMA solves this problem by allowing devices to communicate directly with memory. The main purpose of DMA is to improve the efficiency and speed of data transfer between hardware devices and memory. Now let's understand how DMA works. DMA works using a special hardware component called a DMA controller. A DMA controller manages the data transfer process between input or output devices and the main memory. The process starts with when a device such as a hard drive, network card, or sound card needs to transfer data. First, the device sends a request to the DMA controller. After receiving the request, the DMA controller asks the CPU for permission to use the system bus. The system bus is a communication pathway that connects the CPU, memory, and other hardware components. When the CPU gives permission, the DMA controller takes control of the bus and starts transferring data directly between the device and memory. During this process, the CPU doesn't need to manage every single byte of data. After the transfer is complete, the DMA controller sends an interrupt signal to inform the CPU that the process has finished. This allows the CPU to continue other tasks while data transfer happens in the background. There are several types of DMA transfer modes. The first one is burst mode. In the burst mode, the DMA controller transfers a large amount of data continuously. During this process, the CPU has to wait until the transfer is complete. This mode is fast because the DMA controller can transfer data without interruption. The data type is cycle stealing mode. In this mode, the DMA controller takes control of the system bus for a short period of time to transfer data. The CPU can still work, but its performance may slow down slightly because the bus is shared. The third type is transparent mode. In the transparent mode, DMA transfers data only when the CPU isn't using the system bus. This method reduces the impact of CPU performance, but the data transfer speed is usually slower. Now let's talk about the advantages of direct memory access. The first advantage is faster data transfer. Because DMA allows direct communication between devices and memory, large amounts of data can be moved quickly. The second advantage is reducing CPU workload. Without DMA, the CPU must control every transfer operation. With DMA, the CPU can focus on executing programs and calculation. And the third advantage is better system performance. DMA improves the multitasking because the CPU and data transfer process can work at the same time. However, DMA also has some disadvantages. One disadvantage is that DMA requires additional hardware such as a DMA controller, which can increase system complexity. Another disadvantage is that incorrect DMA configuration can cause problems such as data corruption or conflicts between devices. Security can also become a concern because DMA devices can access memory directly. Modern computer systems use protection methods to prevent unauthorized access. Direct memory access is widely used in many modern technologies. For example, storage devices such as SSDs and hard drives use DMA to transfer files quickly. Network devices also use DMA to move data between the network and memory efficiently. Graphics cards use DMA to transfer image data and improve graphics performance. Audio devices use DMA to process sound data without disturbing the CPU. In gaming computers, DMA helps the system handle large amounts of data quickly, which improves performance and responsiveness. In conclusion, direct memory access is an important technology in computer architecture. DMA allows hardware devices to transfer data directly to and from memory without requiring constant CPU involvement. It improves the transfer speed, reduces CPU workload, and increases overall computer performance. Without DMA, modern computers will be slower and less efficient when handling large amounts of data. So that's all for the material. Thank you for listening. I hope the presentation helped you understand to the concept of direct memory access. Thank you.